So we want to calculate the regression coefficient for a least squares regression model, right? So calculating regression coefficients. And remember, the line of regression is also known as the line of best fit. So let's suppose you're given a set of data where they tell you that the sum of x is equal to 47. They tell you that the sum of y is equal to 45.75. And let's say the sum of x squared is equal to 329, as well as the sum of y squared equal to 389.3125. The sum of xy is going to be given by 310.25 as well, and n is equal to 8. So let's suppose I want to calculate the regression coefficient, b, in this case. What does that mean? It means that firstly, we've got our line of regression, which is y is equal to a plus b x. Under regression, this is built on the concept of mean. So this is actually y bar is equal to a plus b multiplied by x bar, and calculating that b value is what we want over here. Okay. Now, that b value over there is calculated by a formula which says you have to take sxy over sxx for this particular. So the sum of squares of x and y and the sum of squares of x divided by each other, then you will get that b value. Okay? Alright. So let's go ahead and try and find each of those parts. Our focus is to get the top part here, sum of xy, sum of xx divided, and then get b, which would get me that. And then I can get closer and closer to finding the line of regression, which I can then draw between a set of data. Alright, so sxy, remember, is given by the sum of xy minus the sum of x times the sum of y over n. And the sum of xx is given by the sum of x squared minus the sum of x, which we've seen before, over n, right? So in this case here, it's a matter of knowing and understanding this formula and which one to use. When you have x and x, remember it becomes squared. When you have x and y, you find the sum of xy, but then you find the sum of x multiplied by the sum of y divided by n. That's the second part of the way, where you're calculating, in this case here, sum of x squared divided by n. This would mean I would then substitute 310.25 now, and sum of x being 47 times sum of y, which is 45.75. Substituting straight from there, okay, and dividing it by 8, getting me the sum of xy to become 41.46875. The sum of xx takes the sum of squared, which is going to be 329, minus the sum of x all squared, which is 47 all squared, divided by 8. And then I put all of that on a calculator, and it becomes 52.875. Okay. Now, if I divide these two numbers, I end up with my b value over here. So the sum of xy is going to be 41.46875 divided by 52.875 by that. Okay. And that comes to 0.784. So now I know what this is, 0.784. I can put that in the equation. I can say, therefore, well, y bar is equal to a plus 0.784 x bar. All right. So if I find the mean of x and if I find the mean of y, then I can substitute the mean of x in there and the mean of y in there, and then get the a value. Now, the mean of x, or x bar, is given by 47 over 8, and y bar, which is the mean of y, is given by 45.75 over 8, and I can then calculate that one separately. So 47 divided by 8 is 5.875, and 45.75 divided by 8 comes to 5.719. 5.719. Okay. Now, y bar over here, this is going to be 5.719 equals to my a value plus 0.784 multiplied by 5.875, and then taking that, so I'm just going to solve it, subtract the right hand side on the left, 0.784 times 5.875 comes to 1.113. All right, and that's going to be my a value. And now I've got my line of regression complete. Therefore, I know it's going to be y bar equals 1.113 plus 0.784 x bar. When I draw this line of regression, I can see that that's going to be my 1.113, which is my y-intercept, and that's going to be my gradient as well. Okay, so that's my a and b value in the intersect, and I'm done.